Hello all, welcome to our next session in transportation engineering. I hope you have seen the lectures up to the transition curve. We are in the geometric design topic under highway engineering, if you remember. So we have seen so far under geometric design, cross-sectional elements and side distance and super elevation, and also we have just completed the topic of transition curves. Okay, so the next session we are going to see setback distance and curve resistance, which we should have studied under the topic of horizontal curve still. Okay, so this also the one of the topic we are going to see, one of the topic which is coming under the horizontal curves. Okay, so before going to setback distance, you should note some one mark, objective type of question they may ask you for this curve resistance. When a vehicle is traveling in a straight road, if you see when a vehicle is traveling in a straight road, as the figure is given, okay, when a vehicle is traveling in a straight road, whether it is a front wheel driven or a back wheel driven, real wheel driven means a back wheel driven. Okay, so when a vehicle is traveling in a straight road, obviously the tractive force will develop, right? Because the wheel is rotating in this arrow mark direction, the tractive force will develop like this in both the front wheel and back wheel. Okay, so obviously you know this is the tractive force. You can this is the force generated between the rotating wheel and the tire, almost something like a friction. Okay, so when it is driving the engine, the both the front wheel also will having a tractive force of B, back wheel also will be having a tractive force of B. Okay, so when the vehicle is negotiating a horizontal curve, so consider the horizontal curve started here. This is a straight road and there is a horizontal curve. Okay, so this is a straight road. So you try to imagine such a situation where the back wheel is still in the straight road. So the back wheel is experiencing the P, but the front wheel is in exactly in the horizontal curve. Okay, so the front wheel is going to experience P cos theta. Okay, if it is a straight road, it will experience P. Since it is a horizontal curve, it started negotiating a horizontal curve, so it is going to experience only P cos theta. P cos theta, if you substitute any theta, so anyhow this P cos theta value, if you see, this will be less than P. Okay, so obviously the tractive force experienced by the front wheel is less than the tractive force experiencing by the P. Since the engine is same, we are losing some force. Say engine is supposed to give you the same amount of force, so the we are losing some force when the vehicle is negotiating a horizontal curve. How much we are losing? Usually we should have got P. Now we are getting only P cos theta. Okay, so the force we are losing is nothing but P into 1 minus cos theta. Consider if the theta is like 90 degree. Okay, if the theta is 90 degree, so if you substitute P into 1 minus cos 90 is 1, right? So sorry, cos 90 is 0. So give me 1 second. 0 degree, 90 degree. Okay, sin is 0 and 90 is 1 and cos is 1 and 0. So cos 90 is 0 degree, 0, so which will give you 1, and cos 90 degree will give you 0 value. So when the vehicle is negotiating a, okay, so I will explain, sorry, I got made you a little confused. So let's say that theta is 0 degree. Okay, theta is 0 degree means the vehicle is going in a straight line, right? Okay, so then the theta cos 0 will be 1. So 1 minus 1 is 0. So there is no loss. Understood? So we will see some more cases. You can substitute different cases. We have one problem also. I will show you. So at what angle you are turning your front axle, okay, whether it is 30 degree or 45 degree, we are going to lose some power which supposed to you should get for P, but we are losing some power, okay, while we are negotiating a horizontal curve. This is also called as a curve resistance. Okay, so this is also called as a curved resistance, and we are losing some power which is given by P minus obviously P cos theta. Okay, so you can note down this formula, and we are going to solve anyhow 1 or 2 examples in this topic at the end of this session. So in that session I will see how to apply this formula also. Okay, so coming to the next topic called setback distance. So when there is a horizontal curve something like this, okay, so consider there is a horizontal curve and consider there is a left moving vehicle A. So this vehicle A, to see this vehicle B, consider it is a to see this guy, okay, consider he has to see this guy. So we have to clear some distance. Okay, I have drawn very, consider the curve is little more steeper. Okay, so to see this guy we have to clear this much of area, or else you won't see this vehicle B. Okay, so this is nothing but a setback distance. Understood? So I have to clear some distance so that the vehicle A can clearly see vehicle B before the side distance. You see, before this side distance, this is the vehicle A and this is the vehicle B or some object. Okay, how much distance you should clear? You can see this figure is more exact. How much distance I should clear so that the vehicle A can clearly see the vehicle B before his side distance. I hope you know what is side distance. Okay, if the vehicle couldn't see before side distance, obviously the vehicle A will crash with the vehicle B. So how much distance you should clear in a horizontal curve, that is at small m, so that the vehicle A can be clearly seeing the vehicle B. Okay, so this is the informal definition. The formal definition is given here. It is the distance from the central line of the entire road. You can say something like this. So consider this is the road, this is the road. So this is the central line of the road. Okay, so this is the center distance from the center line of the entire road to the nearest obstruction. You can see whatever I am reading, you can compare with this small m. So this is center line of the entire road to the nearest obstruction on the inner side of the road. To have a proper side distance over the entire length of the curve is called setback distance. Clear? So you can once again pause the video and you can try to understand. As per informal definition, it is the clearance distance. How much I should clear so that the vehicle A can see the vehicle B or any obstruction. Okay, so for single lane road, okay, let's see for first the single lane road. Take a case of single lane road. In that, let us assume our length of the curve, okay, length of the curve is greater than or equal to the side distance. Length of the curve means, consider the curve is something like this. The curve means the horizontal curve. Okay, the curve is something like this, and this is the arrow mark. Length of the curve is here, and the side distance is lesser than that. Okay, so length of the curve is greater than side distance means the vehicle A and vehicle B both are in the curve itself. Okay, they are not in the straight road, they are in the curve itself. So in that case, you see, I can draw this arc. See, I have taken an arc from that particular case. So we know this is vehicle A and this is vehicle B. The total distance is side distance. Okay, the arrow mark, the curve length is side distance, and this is m. Okay, so and this is the radius. So how to determine m? M can be determined by OA minus OB, right? So m can be written as OA minus OB. What is OA? OA is R. What is OB? You can take this right angle triangle and then using the Pythagoras theorem you can determine this OB. You will get OB as R cos alpha by R cos theta you will get anyhow. So R cos alpha by 2. You will get, you can pause the video and then do this right angle triangle Pythagoras theorem. So this will be your OB. When you substitute this OB, R minus R cos theta by 2 will give you the setback distance for the case of single lane road where the length of the curve is greater than the side distance. Okay, and you should know what is alpha. You can see the alpha is nothing but tan theta, right? Approximately tan theta is nothing but opposite side by adjacent side. You can see this is alpha, opposite side is S divided by R. Okay, so this should be written in this. Obviously, whenever the theta or alpha are separately calculated, it will be in the term unit called radian. but when you want to substitute here, you have to substitute into degree, okay, because that's how it is valid. So to convert that, you have to multiply by 180 by pi. I hope you know the unit conversion from radian to degree. Okay, quite simple formula. There is no formula, it's just a geometry. Okay, so r minus r cos theta by 2 or r minus r cos alpha by 2. You can say alpha or theta. Okay, so this is case 1. So case 2, consider when your length of the curve is small. So consider, I will make sure the clear diagram here. Vehicle A is here, vehicle B is here. Consider. So this is some straight road, and this is a horizontal curve, and there is a straight road. So the curve is very small. Understood? The curve length is very small, but the side distance is very high. Side distance is higher than the curve. Horizontal curve is very small. So consider when the case where the horizontal length is very small, but the side distance is very high. So then you will get the figure something like this. Okay. So if you see, the side distance is very high compared to the length of the curve. So when you can see, so try to draw this figure, try to understand this figure. You will have two right angle triangles here. This is a straight line portion. You can see the blue color what I am drawing is a straight line. Okay, the curve is only from this point. I can show in some other color. The red color is only the curve, and the blue color is a straight line. So you can, this is the arc length. Okay, so you see now what is the setback distance. I will show you. You can see the pink color. Now I have to see, consider the vehicle A is here, vehicle B is here. So the distance I should clear for the setback distance is the pink color what I have drawn, which is nothing but AD, which is nothing but AB plus BD. Okay, from the previous theory, last slide we have derived, as per geometry, AB should be r minus r cos theta by 2. Okay, very good. So only thing now we have to find is BD. Understood? AB we already know, only we have to find BD, so that we will know this one. What is BD? BD is, now I will show in another color, this distance. Okay, this is this distance I want. For finding that distance, I will take this right angle triangle. I will show you here. So take this right angle triangle to find BD. Okay, so right angle triangle CEF, you see CEF, and you see this is alpha by 2. Okay, I am drawing just drawing the same. So CE, or you can say it as a BD. They both are same, right? You can see the figure, both are same. So now we know this hypotenuse length. What is the hypotenuse length? Obviously it should be S minus LC by 2, right? LC is the length of the curve. Okay, total distance is S curve length minus LC. The left side LC by 2, this side also you can write same, S minus LC by 2, right? Okay, so now if you put sine theta, you will have something like this. Sine theta is equal to opposite by hypotenuse. Opposite side is CE or BD. Both are same. So if you equate this one, S minus LC by 2 into sine alpha by 2. So now you got BD. Okay. So now you know already know AB and you know BD. Adding both will give you the setback distance for the case L less than SI distance. R minus R cos alpha by 2 plus S minus L by 2 into sine alpha by 2. So now I hope you understood clearly. We got two formulas now. R minus R cos alpha by 2 plus S minus L by 2 into sine alpha by 2. Okay. So as per the formula, you no need even memorize, but anyhow, if you cannot remember the formula, you cannot derive in the exam. I hope it is very easy. Okay, you can replay the video 2-3 times, you will understand, or you can pause the video and you will understand, because total derivation was there in the slide. If you didn't know, there is an approximate formula to memorize. Approximately you will reach the answer. For the case, first case, length of the curve greater than side distance, m equal to side distance, s is side distance, okay, s square by 8r. For the case 2, L into 2s minus L divided by 8r. Okay, you can memorize this formula. This formulas also will give you that answer. But anyhow, you know it. If you cannot memorize those things, you can memorize just this one. Okay, but if you know that, then no need to even memorize this one. Okay, so anyhow you can use it. I did for my exam. I memorized this formulas also. Okay, to cross verify whether my answer is correct. Okay, so now we are going to extend this idea for multi-line road. With that, this topic will be over. So when you are having a multi-lane road, You see, first I will draw the road so that you will understand clearly. So consider this is the multi-lane road. Okay, so the center line of the road I will draw in this color. No, sorry. The center line of the road is, let me draw in this yellow color. Okay, so okay, always you should remember that m setback distance is calculated with respect to center of the road. Okay, center line of the road. So that yellow color whatever I have drawn is the center line of the road. Okay, but okay, this is however. Okay, you should know that setback distance is always taken from the center line of the entire road. All the formulas whatever we have derived is from the center line of the road. Okay, so for multi-lane roads, vehicle traveling at center of the inner lane, somewhere here. Okay, center of the inner lane is this one, right? Innermost lane is this one. The center of the inner lane, the side distance is critical. Critical side distance is this center of the inner lane. The red color line I am showing you. Okay, so which is at a distance of d distance from the center of the road. You try to understand the critical distance is we need to know the side distance required for the center of the inner lane. Only this road is more critical for the vehicle A. This vehicle is more critical compared to the here. This vehicle can obviously see everything clearly and then that guy can go safely. So this guy, center of the guy who is traveling at center of the inner lane, he should have the sufficient setback so that he won't collide. Okay, so this guy is more critical. Where that guy is traveling, he is traveling so far in the single lane road wherever you used radius, we have to modify that formula with r minus d. You try to remember the previous formulas we have derived like something like this, right? We have carried a formula with respect to r, right? Now in this case we are going to do with the curvature with respect to r minus d. Okay, so what is d? D is the distance between center of the road. Consider there is a two-lane road. For your more clarity I will tell you. So consider this is a two-lane road. The center line of the road to, okay, so sorry, two-lane road cannot be. Okay, let it be. So total width of the road is 7 meter, right? Let us consider 7 meter or 7.5 meter for more clarity. Center line of the road is at 3.75. So the distance between center line of the road to center of the inner lane, the distance between there is red color and yellow color is that small d, right? So we know center of the road is at 3.75 meter. To center of the inner lane is, that will give you d is nothing but divided by 2. So which will give you approximately 1.9 meter always. If they give you the question related to two-lane road, okay, so the d distance is 1.9 meter. So you no need to even memorize the formula. You try to understand. It is the distance between center of the road to the center of the inner lane. Okay. So even further for more clarity, I will draw once again. If there is a two-lane road, try to imagine what should be the distance between this red color and blue color. That's it. This is what I am trying to make you clear. So the guy who is traveling in innermost lane is the critical guy, then the guy who is traveling at the outermost lane. So we will modify the setback distance for the guy who is traveling at the innermost lane. How we are modifying, you can see for the case 1, initially we had a formula r minus r cos alpha by 2. If you remember, for the case 1 we solved this one. Here instead of r it will be r minus d. Okay, so if you remember the OB distance we carried, right? That OB distance now it will be same OB distance, the right angle triangle will be taken at r minus d location. Exactly, here also the change will be r minus d, because in case 2 also, if you remember, we have used the formula from case 1, right? The same location, the same formula when we are using, I am using r minus d cos alpha by 2. That was the change 1. Second change you should know is, initial case okay, you can neglect this one, you should use this one. Initial cases we have used s by r, right? Opposite side by adjacent. In this case it should be s by r minus d will be the alpha value. Okay, the angle will be opposite by adjacent. I told you initially it was the case 1 it was s by r. For multi-round road you should use s by r minus d. Okay, so similarly for length lesser than side back distance, in this case also we should use a formula. Initially we used L by R for single lane road. Now we should use L by R minus D. Remember, all the formulas you will get in radian, then you have to convert to degree by 180 by pi. That is separate topic. But anyhow, so there is no big change. Whenever there is a multi-lane road, you should be able to determine R minus D. Okay, so wherever R radius was used for the OB distance derivation, if you remember the derivation, you can replay the video, go to case 1 and see how that OB distance we calculated. Here instead we have to use R minus D. That is the only change. Then the formulas are very simple. Okay. So with this I will close this session. We will solve problem related to curve resistance and setback in the next session. Thank you.